Okay. Hi, everyone. I just want to welcome you to this session. So this session is going to be with Philip Pipes, who's going to be talking to you about Let's Encrypt, automate all the things. You ready?
Yep.
Fantastic.
All right. I think this might be the 15th or 16th time I've taught this tutorial. So if I'm going too fast, please stop me because I'm just on autopilot. So, for the benefit of the internet as well, hello, internet. My name is Philip. I wear many hats. I'm not sure which hat I'm wearing today. I think I'm just wearing my general troublemaker hat. This is not so much a tutorial about Let's Encrypt as a tutorial about automation. Um, Despite having taught this same presentation for several years now, I still encounter invalid certificates or expired certificates with distressing regularity. So one of the things Let's Encrypt forces you to do is automate. And for reasons I really can't fathom, people are still refusing to automate. So you get this Let's Encrypt certificate, which is valid for 90 days, and then 90 days later it breaks and you remember that, oh, hey, I should go renew it. And that's not the way it's supposed to work. So this tutorial, I'll go into a little bit of background of Let's Encrypt, which hopefully everyone has heard before, but it's very soothing if I recite it again. And then after that, I'll do a little demo of how I have automated my Let's Encrypt pipeline using the DNS, which is similar to how the FreeBSD project does theirs. And in fact, it's almost an exact copy of that. So without further ado, let's get into this. And nothing works. Oh, great. Aha. It works if I focus the screen. So historically, if you wanted a certificate for your website or whatever, you would go through a four-step process, roughly. You would go and generate a certificate, which usually involves chanting mysterious incantations at the OpenSSL command line or clicking buttons in IIS or doing whatever it is you do to just get a bunch of base64 encoded blobs out, one of them called private and one of them called public. And you manipulate these blobs into a certificate signing request, which has more unspeakable horrors in it. And you put all of these things together and you send them to a certification authority to sign. And this usually involves a financial transaction. You give them money and they rent you a certificate for a certain period of time, a year, 3 years, a useful chunk of time. And then you do this again every year, or parts of this every year. You might keep the key for 20 years and just reissue the certificate annually. But the point here is that every year you go and talk to some certification authority, some entity in the sky on the internet, you give them money and they rent you a certificate. They rent you a base64 encoded blob of numbers for a certain period of time. Annual repeat. So I don't want to go on too much of a philosophical tangent, but this is fundamentally a flawed system, right? So the certification authorities are answerable to their shareholders. They are not answerable to you. They are not answerable to the greater internet goods. Their primary objective is money. They are in the business of taking your money and renting you a string. And the more strings they can rent to you, the more money they can extract from you, and that is all they care about. But also, anything that you do annually, you tend to do manually. And anything you do manually, you are setting yourself up for failure because you will forget. Or you'll forget in two ways. Either you'll forget to do it, or you'll forget how to do it. And more often than not, you'll forget both. So when that happens, you end up with things like this. This is a pretty old example because as I said, I've been teaching this for a long time. When you forget, or when you do it wrong, your web browser or whatever it is you're using to verify that certificate is going to complain, I cannot validate it, right? This is familiar. And when you see this, what do? You click yes, yes, okay, everything's good, fine. And you train yourself to be exploited, right? Because one day you will just bypass something that matters and send a whole lot of money to somewhere you didn't intend it for it to go. So let's encrypt. They've been around for a long time. Yes, question. What? For the benefit of the internet, hold your question until you get a microphone. You are not allowed to ask anonymous questions here.
Okay, so thank you. What is the logic behind the certificate renewal time is 1 year annually? Because when we renew the certificate every year, we have to also do work on the dependent applications also.
Yes. So historically, the 1 year was, I think, as far as I can tell, and I'm a horrible cynic, is the sweet spot between the period of time the certification authority can get away with and the period of time that is convenient for you to do your manual process of renewing your certificates. So 1 year feels about the sort of value you get if you send $30 or $100 or whatever the number of the year is to the certification authority. 1 year feels like you're getting some value out of it, right? So you go and rent the certificates. If it's $30 a month, you're not going to rent your certificate. If it's $30 a year, you're probably going to do it. Historically, yes. So the 1 year, well, that's my cynical view of the world. Historically, it was just, that's what they could get away with. Maybe more historically, 1 year is how often you want to argue with your configuration.
Because money flexibility depends on the organization, and as an organization and as also a big team, I found that I have 5,000 employees organization. I have just few 15 or 20 dependencies, which I update after every certificate.
Yes.
So there the money is the dependencies. I think it's a big issue. I thought there is a behind any security issue also or anything from the vendor side or anything.
Well, as we'll see later in this presentation, you don't want to do this every year. You want to do this every 3 months, or you want to do this every month, and you want to automate your dependencies away. So that's what the rest of this presentation is about. If you're doing it manually, I think, yes, you have a good point. If you're doing it manually and you have an organization with 5,000 employees, you probably have paperwork and documentation and purchase orders and people to convince that you need to renew your certificates. So the 1 year period is 6 months of operational, and then after 6 months you start the process of renewing it, and then the technical step of renewing it is a small detail. But yes, so the 1 year is just an arbitrary number. I don't think it could just be a random number, but I think it's the sweet spot between giving you value if you are paying money for your certificates. It's also the sweet spot if you've got a bureaucratic process for requesting funds and actually renewing your certificate for money. It's just 1 year is a convenient period of time for all sorts of reasons. But 1 year is the past, right? That was 20th century certification authorities. We live in a 21st century. We've been living in a 21st century for a very long time now, and we don't play this game anymore. If you're paying money for your certificates, you are probably doing something wrong, right? So Let's Encrypt is a not-for-profit certification authority. I have nothing to do with them. I'm merely a user. They have been around for, I don't actually know how long they've been around, for longer than I've been doing this presentation. And they looked at this model of renting certificates for a certain period of time, and they went, no, this is not sustainable. This is not good. And they set up a free version. So it's free. They also set up an automatic version. So instead of you dealing with this entity and convincing them that you are who you say you are, you just jump through a domain validation dance. You just convince them that you have control over the domain name that you are trying to get a certificate for, and they will take your word for it. They don't go and check your business registration. They don't go and check your name. They don't do any of this. They just go and check, can you control this domain? They want to be secure, obviously. It's a certification authority, security is a thing. They also want to be transparent, open, and cooperative. Transparent in the sense that you can audit who they've issued certificates for. Transparent also in their processes and in the way they use their software. Open in the way the rest of the internet is open. You can participate in their community. You can give suggestions on how they operate their processes, and also cooperative. So they're working with you. They're not working for you. They're working with the internet community, trying to improve the overall security of the internet, not merely making money like the traditional certification authorities. So that's the added value that Let's Encrypt proposed. More recently, there's a couple of other providers of free certificates. Zero SSL is one that's rather large and is very credible. I have nothing to do with them either. I just know them because they're the default of the implementation of the Let's Encrypt protocol I use. There are several others. This one has a free plan that's substantially identical to Let's Encrypt. So it lets you issue an unlimited number of automatic certificates using this ACME protocol. I'll explain in a bit. You could also give them money. So they seem to have found a middle ground between, we'll give you all the certificates you want for free, just like Let's Encrypt. But if free certificates are too free for you, we also offer you money. Right? So they will take your money, and in return for your money, they will give you monitoring. They will also give you 1-year certificates if for some reason you have not been listening to my tutorials for the past several years and you are still going through a manual process of updating your certificates on every machine. They also offer APIs other than ACME and other things. Again, this is not an ad. I have nothing to do with these people. I just know they exist. Let's Encrypt. I have nothing to do with them either. I'm just a happy user. Which of these should you use? Whichever one you like. If you're happy to install a default configuration and it gives you zero SSL and it gives you pleasure, great, stick with that. If you install it and Let's Encrypt is your provider, you're happy with that, great, use that. If it's another one which I've not named in these slides and you're happy with it, that's also fine. Right? The point of this presentation is not to advertise one certification authority over another to you. The point of this presentation is to encourage you to automate the process. Right. So how does this Let's Encrypt process work? Historically, the first implementation or the first stab at this process was everything on the internet is a web page. We run a web server on whatever the thing is we need a certificate for. So we set up a web server here and we go and ask Let's Encrypt, hey, can I please have a certificate for example.com? Let's Encrypt says, well, sure, you can have a certificate for example.com if you can prove that you control example.com. How do you prove that you control example.com? Well, go and create a file called ed98 on your example.com/8303. If you put this magic number at that magic address, we, the Let's Encrypt robot, are convinced that you are who you say you are, and we will issue a certificate for you. It's a little bit more complicated than that, but that's roughly how it works. You then get your certificate out of this. You put it on your web server, manual process, all the same, everything's good, and you are happy. But the certificate they give you is only valid for 90 days, 3 months. So 3 months later, you need to go and do this dance again, right? Example.com, they'll give you a new magic number because, replay and all that security goodness. 3 months later, you need to go do this again. Are you going to do this manually after 3 months? Hopefully not, right? And yet, right? This is distressingly common. I see Let's Encrypt encrypted web pages, which 90-day validity, and the certificate has expired 3 days ago. And sometimes I go and look in the transparency logs and I find they've been doing this for years. So, whoever's job it is, thankless, soul-crushing job it is, every 3 months to go and replace the certificates has gone on holiday or is ill or lost their keys or something. And it, they're still doing this manually. This is terrible. You don't have to live this way. So let's talk about how this thing is meant to work under the hood. So there's a protocol underneath Let's Encrypt and Zero SSL and possibly several other providers called the Automated Certificate Management Environment. When I first gave this presentation many years ago, it was still a draft. It's now RFC 8555. You can go and read it. It's not a very complicated protocol. It'll put you to sleep because it's a standard, but it's essentially a JSON-based protocol over HTTPS. So you get from them a blob of JSON encoded data. Please put this there and do this, and we'll give you that. And it's easy to implement, and there are several implementations of this protocol. So the reference implementation is certbot. Who runs certbot? At least 2 people, and maybe some people who are unwilling to admit it. Certbot is a reference implementation. Like every other reference implementation, it's huge, it's bulky, but it works. It has a lot of dependencies, and it tries to do a lot of things. So it will, if you install certbot, yes, question.
443
Oh,
port.
try.
I am actually using the certbot, but only support for a port 80. It's not support for a 443.
We were coming to that. Yes.
Thank you.
Does certbot only support port 443 and not port 80? We are coming to that. What you want is port 53. I have a third port for you. And I'll tell you a secret, so you could run this on any port you like. But yes, so certbot is certbot operates mostly, certbot does a lot more things now than it did when it was originally created. Mostly assumes a world where all the world is a web server and you want a certificate for your website. So it will try to bind to port 80, and it will then do the ACME dance with Let's Encrypt. Certificate comes out, and it is then going to configure your web server, whether it's Apache or Nginx or Lighty or whatever you have. And it's going to do that all for you. And it's going to assume that you have installed your machine exactly the way they have installed their machines. So it's a really nice reference implementation. And as long as your system conforms to their assumptions of the world, you are going to have a really good time with certbot. If your system is in any way different from what the reference implementation assumes, you are not going to have a good time. Also, the world has moved on a bit from websites only needing encryption. There's other devices out there. It's amazing what people connect to the internet these days, anything from light bulbs to shower heads. And all these things ideally should have some form of encryption around them, because the alternative is sad and terrifying. And certbot doesn't really cater to these other things that should also be secure. Happily, the protocol, as I said, it's a standard. Anyone can implement it in any way they like. And the last time I went to look at this webpage last night, as it happened, there were more than 100 implementations, or hundreds of implementations of this protocol on the let'sencrypt.org webpage. I'm just going to talk about acme.sh, which is the one I happen to use. Why am I using it? Because it works, and because the guy I copied my instructions from was using it. There's many other implementations in every language known to man. The nice thing about acme.sh is it's a tiny, tiny little shell script, and it's just shell script. It doesn't need anything other than a POSIX compliant shell. It doesn't even want bash. It can use bash if you have bash. It doesn't need bash. There's other small implementations as well if you like. I'm just going to talk about this one. If you don't like it, great, use another one. But whatever you do after you leave this presentation, if you're doing things manually, stop. Right. And if you need help, I'm happy to hold your hand and automate. So how does acme.sh work? Well, in a nutshell, you go and clone their Git repository, or you install a package if your package manager has it. But their installation instruction does exactly three things. It goes and copies itself into your home directory. It creates an alias in your .profile, and it adds a cron job to check your certificates every day. Note, it does this every day. It doesn't do this every year. It does it every day. Every day it goes and checks, is my certificate due for renewal? Yes, I will go and do the robot thing and renew the certificates. But what it's going to do is renew the certificate. It's not going to put it anywhere on your system. It's just going to renew the certificates. Anything that needs to happen with the certificates, that's your job. So, it's a blunt tool. You get a certificate, and then you do with the certificate what you like. And we'll talk a little bit about the options in a bit. So I could go through this presentation and bore everyone to tears, but it's much more fun if you watch me set my laptop on fire. So let's get out of this presentation, and there we go. The fun begins. Nothing works anymore. Good. Oh, excellent. Something panicked. Fantastic. Is Zoom still on? Oh, am I still on the call? No? Aha. This is why you come to these presentations in person. Okay. That's a fun one. Dear Apple, no. You cannot know. Can I join this call again, Chris? Technical difficulties, please hang on. Hmm? 1 moment, please. Okay. Where am I? Where am I? Zoom. Zoom. So of all the things that could have failed, this is not one I expected. I did not expect my Windows server to crash. Okay. Join with audio or without, or just leave it mute. Hello again. Share screen. Oh, you have disabled screen sharing. This is why I should not be the first presenter at a conference. Oh, hello. Oh, I miss my cat. Okay, let's try that again. Share. Catch fire. I'm not hearing anything, and that's good. Where was I going? I was going to a terminal window. Oh, hey. Oh. The terminal window I had painstakingly prepared in large friendly letters has gone. All right, that's okay. I shall just log into this machine again. And because I am not completely stupid, I've put this in a demo. Minimize this. Okay, everyone's on the boards. Okay, good. So I'll have another window open. Here we go. Larger. I am the proud owner of the trouble.bot domain. It's because renting strings on the internet is what I do. Trouble.bot is mine, and I would like a certificate for demo.trouble.bot. So let me just do that quickly, and then let me talk you through it. Spell it right. Okay. So imagine that I would like a certificate for demo.trouble.bot, where I might want a web page, or that could be my printer, it could be my shower head, it could be my smart light bulb, it could be anything. All that matters for the purpose of this tutorial is I want a certificate for it. So I'm going to just add it to the DNS. There is my, well, that's the magic. Let me just commit this. trouble.bot. See, I see right through that thing as laser eyes. Yep. Bots. Okay. So if you wanted to get a certificate for demo.trouble.bot in the historical way, you would first be typing OpenSSL, blah, 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 incantations. You would then get a certificate signing request. You would go to a page, paste in a blob of base64 encoded text, and eventually you'd get a certificate out, right? That's not what we're going to do here. I'm just going to, all I have done is I have added a magic string to my DNS zone file, right? That's all I've done. Let me just push it because automation is a thing. Right. So my DNS pipeline involves me git committing, and then automation will go in DNSSEC sign it because DNSSEC is also a wonderful thing. And while this is happening in about a minute or so, DNSSEC will notice that there's a new name to sign. My zone file will be signed, and this magic string will be in the DNS and and ACME Let's Encrypt, my tiny little shell script, can go and use it for its nefarious purposes. How do I now get a certificate? How do I make this go away? There we go. So I would like a certificate for this name, please. I would like a certificate for demo.trouble.bot. Right, that's the name I want the certificate for. It's at the end here. Don't worry about anything else on the screen yet. Just watch the magic. So the magic is going to happen. So this is where you are singing your generate my domain, generate my certificates. The certificate has gone here. It's helpfully put in a file. And now the script is doing all of this unattended. All I've done is just do the thing. And when I was testing this earlier, it took about 20 seconds to run. Of course, because it's a demo, it's going to take several hours before this happens. Well, it's up to 10 minutes. So worst case, you're going to listen to me talk about this for 10 minutes. Hopefully not, but we'll see what happens. Has everyone been enjoying Bangkok this week? Right. If it doesn't immediately issue it, I will go back to slides for a moment and watch my laptop panic again. Give it another 10 seconds, maybe. No. Okay. Let's talk through this. I do have backup slides because demos never work. Aha. There we go. Better. Hooray. There we go. So that issue, that was this entire process was the generate a key, turn the key into a certificate signing request, send the certificate signing request to your chosen certification authority, give them money, download your certificates, and now what? Right. So this was me typing one command and a shell script. I think we all agree that this was a little bit easier than the cumbersome manual process of dealing with some entity, right? So let's talk about how this works. So this is the certificates, and you just paste this into your web server, or you put it wherever you like, and the key is in the file it tells you about. And now every month there's a cron script on tab ISL. So every day this little robot is going to go and look, is this still valid? Is this still valid? Is it still valid? And about a month before it expires, it's going to renew the certificates, all without you doing anything ever again. Right. So every month the certificate is going to renew. And the only thing you had to do to issue the certificate is add a magic string to the DNS. And the only thing you need to do to keep the certificate fresh is not touch anything. right? So as long as that magic string continues to exist in your DNS configuration, your certificate will continue to renew indefinitely. Is this useful by itself? No, of course not. It's just renewing certificates for you. The power of this automation is that it can run completely separate from your target device the certificate lives on. So your certificates, this certificate might be destined for a printer, or it might be destined for a smart light bulb. It might be destined for any device anywhere deep in my network that has no web server anywhere near it. There's no websites were harmed in the issuance of this certificate. No websites will be harmed in renewing the certificates. This is completely DNS based. The way this works is you add a name to the DNS, and ACME, or Let's Encrypt, your chosen certificate authority, goes and checks whether you have control over the DNS. And what you then go and do with the certificate is completely up to you. The implementation I use is a shell script and has a whole bunch of hooks. So if we go and look in what ACME has, it has a whole bunch of deploy hooks. Some of these might be familiar to you. So every time a certificate is renewed, my shell scripts can go and configure the Apache web server. It's going to take the renewed certificate, it's going to put it where Apache can find it, it will restart Apache for you, and this all happens unattended. You can use other examples. What else is in here that I recognize? Strong Swan, to pick a random crime against humanity. If your VPN server runs Strong Swan, this little deploy hook can go and put the certificates in its PKI tree and then sends SIG user 1 or SIG hub or whatever Strong Swan expects this week to go and restart and use your new certificates, right? TrueNAS is another one. There's a whole bunch of things in here. And the nice thing is all these certificates are pretty small. So if we go and look at one, for instance, let's look at Apache because it's a nice small example. So, well, not implemented yet. Bad example. This is why we test our demos, or not. Let's see. Well, let's look at Strong Swan. Maybe that one's implemented. There we go. So what the shell script does is it goes and checks if a user has been IPsec directory exists. If it does, it goes or if that command exists, it goes and uses that. And there we go. So it just find my certificates, find my private key, put it where Strong Swan can find it, find my certificates, put it where it can find it, find the chain, find all the certificates leading up to it, put them all where Strong Swan can find it, and do a reload. Right, that's a fairly simple example. You can make this shell script as complicated as you want it to be. If you want to run this shell script on your certificate oracle and have it SSH to other machines in your network unattended, you can do that. Right. The point of this is you can put anything in these hooks that you like, anything that makes sense in your infrastructure, you can put in here. Right. So that's the output side of this pipeline is you get a certificate which renews magically every month or every day rather, and it keeps it up to date. About a month before it expires, the robot will start to try to renew it. And by default, if it fails, cron will send you an email because it just writes the standard out. Right? Does that make sense? So this runs somewhere on your network without a web server. Right? So you don't need to expose port 80 or port 443 or anything to the internet. You don't even need to expose your DNS server to the internet. I don't expose my DNS server to the internet. The DNS server this runs on is a jail somewhere locked down, and my real DNS server transfers the zone out. Well, not even my real DNS server, because I over-engineer everything. OpenDNSSEC goes and gets the zone file, signs it, sends it to my real DNS server, and then it goes out to the internet where Let's Encrypt can see it. And then it goes and deletes that challenge again until it's needed the next month. Right. So all you need is you need a way to get a challenge in the DNS. If you can get a challenge in the DNS, you can keep your certificates fresh. Does that make sense? Right. So that's the output side of the equation is what I've just talked about. You can just have all these little hooks, and you can write your own hooks in the deploy side, and this just puts your certificate where you want it. If you're running this on your local machine, you just put your certificate where Apache can find it and reload Apache. You put your certificate where StrongSwan can find it and you reload it. If you have a printer somewhere on your network and you can speak to it, you can send your certificate to your printer and then reload your printer, I suppose. And that works just fine, right? If you have a smart light bulb, you send your certificate to your light bulb and you reload your light bulb, and that works just fine. So that's the output side. Now let's look at how how can you talk to your DNS server, because somehow you need to get strings into your DNS server. This little shell script can do that for you too. It has a DNS API directory, which has a lot of things in it. Who runs their DNS at Cloudflare? Couple of hands in the room. I think it's CF. There we go. If you run Cloudflare, all you need to do is in your shell script, in this little shell scripts environment, you tell it your Cloudflare token, your account ID, and what zone you have. And this little script will go and add challenges to your Cloudflare DNS. And the token you give it, the only thing it needs to be allowed to do is add ACME challenges, right? What else do people run their DNS on? I run, because I'm a cranky old man, I run NS updates. Classic DNS, it sends an update command to your DNS server. It just adds to your zone and then deletes it again. Little shell script, you just run it, you tell it what your domain name is, you tell it the tsig key to sign with, and it goes and does that for you without any further interaction. There's dozens of these in here. If you run Vulture, you can add it to their API. Pork Bun, famous renter of strings, use their API. And it's really easy to implement these little scripts. So if your DNS is custom for whatever reason, you can do this. For my sins, I help run the FreeBSD.org cluster, and we like makefiles. Really like makefiles. So our little implementation goes and puts a fragment somewhere where you can find it. It runs make, and the DNS pipeline takes over from there. It doesn't matter what your DNS pipeline is. If it's something that you can run in a shell script, you can hook it into acme.sh and you can run it automatically. Right. Tuxo, I think you use NS update, right? Yeah. So doesn't matter what you're using. If you can find something and you can find a way to automate putting things into the DNS, you've got the input side of the equation sorted out. The output side of the equation is also limited only by your creativity. If you can encompass it in a shell script, acme.sh can drive it. So every month or every day, it'll go and look, is my certificate still fresh? Yes. Keep it, do nothing. Is my certificate due for renewal? Go and renew my certificates and run the shell script to deploy it where it's needed. Right. So there's a couple of ways you can do this. You can do this really simple. If you have a very simple setup with one domain name and a couple of things under there, you can add your challenges to your zone file and you're done. One really nice thing I like is that the ACME protocol supports indirection, so that you can put your challenges in a different domain, or you can put your cert bots in a different domain than where they're needed. So I run my cert bots on, let me go back up a bit and look at this command line I hand waved over earlier. I run my cert bots on my domain under certbots.trouble.is. That's where this little robot lives, and the little robot manages this DNS zone. If we go and look at So certbot.trouble.is is just a part of my namespace that is helpfully served by Hurricane Electric. Hurricane Electric pulls that zone from my DNS server. Where does that DNS server live? Well, it lives right here. It's the only bind I still run. I've purged bind from my life, but bind does support NS update, so that's kind of nice. So I have a bind running in the same prism as my certbot with a configuration that essentially allows Hurricane Electric to transfer this zone from me. So every time I add a string to my certbot.trouble.is zone, HE comes and fetches it, and it's visible on the internet. When I'm done with the challenge, so when the ACME robot has validated that I am in fact in control of this domain, I delete the string again, Hurricane Electric picks it up, and it goes there. So that's sitting in this one zone. Let's Encrypt doesn't care who I issue certificates for, as long as they delegate this authority to me. So if we go back to my earlier example, this is the trouble.bot zone. You just open the file instead of the log, trouble.bot. So this is the trouble.bot zone, not the trouble.is zone. And I have said demo.trouble.bot, please delegate the ACME challenge responsibility to certbot.trouble.is. So all I do is in the zone where I want a certificate, I create a CNAME to the zone that's responsible for issuing that certificate. So I control trouble.bot. I can delegate responsibility for issuing certificates to trouble.is. In this instance, both of those troublemakers are B, but they don't have to be. There are several troublemakers who, for reasons entirely of their own, trust me with issuing certificates for them, because I've set up all this automation and it works really well. So they create CNAMEs in their zone files pointing at my little robot, and I send them their cooked certificate. Whenever it expires, I send them their certificates, or they have given me access to whatever bit of infrastructure they need their certificate on, and the robot does it for them. Right. And it could be anything. So I could just email you your certificates every time it expires, if that is the sort of thing that gives you pleasure, that you like to walk around with a printed copy of your certificates. I could send it to the printer, right? So my deploy hook could be LPR, where every month or every 3 months, whenever it expires, I print out the certificate. It falls out of the printer, you pick it up and you walk around with your renewed certificates. That is a stupid use case, but it's valid. Right? Does that make sense? But this just the point is you are limited only by your creativity in what you do with the certificates that come out. And on the input side, if you don't want to run if you don't want to implement the automation yourself, you can find someone you trust to do it for you. If you don't want to do this in your main domain because your employer presumably cares that your main domain keeps working, and maybe they don't want anything adding things or deleting things from there, instead of making automation that adds and removes things from your main zone file, add a CNAME, delegate it to some other, a .bot domain. .bot is very cheap. Right. So yes, Nishal has a question.
Hi, yeah, I have a question. So this is a really cool trick. I actually didn't know this. Thank you. But that still requires configuration. If you could switch back to the screen you're on, that still requires an Acme challenge entry, a resource record in the zone file for whoever this is going to be. That's still a manual process, though.
Only once, though. So when you put the service in operation, you add the CNAME. And the only thing you need to add is the CNAME. You're not adding a challenge. You're adding a CNAME to this zone where challenges are added automatically.
Correct. So for every what should we call it? For every domain that I'm going to want an Acme challenge for, I'd still have to manually go in and add that.
Yes.
Without
every domain you want an Acme challenge for, you presumably want to create the domain anyway.
fair. I'm asking if there's a different way of looking at that without using wildcards, for example. I mean, I think wildcards would be universally bad.
Ooh.
So don't say that.
I had not thought of using wildcards.
I think a wildcard would be universally bad.
Yes.
So I would not want that.
Mhm.
Okay. All right.
Right. Yeah. But no. So I know what you're asking, and I think you're right. It's an extra manual step, but it's a manual step that is part of your putting things into production process. So buy a new printer. Where currently the steps you take when you buy a new printer is you allocate the switch ports, you set the description on the switch port, you put the switch port in the correct VLAN. The next step in that process is and add a CNAME for this printer to whatever zone file, whatever zone the printer is in. Yeah.
Oh, there, sorry, Chris Falker. Yeah. Just to clarify, certbot.trouble.is,
Yes.
that is not a root CA server, is it?
No. The internet is smart enough not to trust me with the root CA server.
How does that fit into the chain?
So certbot.trouble.is is a jail that runs on my infrastructure that runs this acme.sh process. So all it is in this picture is it's a DNS zone I can add and remove things to automatically.
Right.
So it's let me switch back to this screen. It's a zone that lives in here in host name. In this machine, there is a bind, and this bind is somewhere, and I touch this so often that I've forgotten where it is. Primary, is it under primary? No, of course not, it's under dynamic. There we go. So this is just a DNS zone that lives on this machine under this bind, which has very little in it. It has nothing in it, in fact, other than a quad A record, which I use for my automation. And it's the named the bind that runs certbot.trouble.is has been configured to accept dynamic updates using a key, which I have helpfully purged from this screen.
Right.
So this bind process allows you to send NS update commands saying add a challenge, or add a text record, delete a text record, add a text record, delete a text record. Actually, it's right at the bottom here. Here we go. This is the policy. I'm not sure if it's large enough to see. I can make this a little larger and maybe panic my laptop again. Here we go. So this bind process allows you to send NS update queries that manipulate text records under that namespace.
Right. Okay.
So all acme.sh has to do is it has to send NS update messages saying add a text record, add a text record, add a text record. So acme.sh gets the text records from Let's Encrypt or from Zero SSL or from your chosen certification authority to prove that you have control over whatever domain it is, which you have CNAMEd to certbot.trouble.is. You add this challenge to the certbot.trouble.is zone, NS updates, add text. Let's Encrypt goes and checks if that text record exists. It goes and resolves the CNAME. It finds the text record. Everything is fine. It issues the certificates. And then acme.sh goes and deletes that text record again. Right. So all you need for this automation to work is one DNS zone you can add and remove records from automatically. I run my own because I'm a masochist and I just like control over all of the moving parts. And also it makes for really fun demos. Gets me to Bangkok to talk about these things, gets me out of the house. But you can delegate this zone to Cloudflare, right? Because Cloudflare has a pretty good API. They're reasonably reliable service provider and they don't cost a lot. I have an example in the slide deck, which is on the Apricot webpage, where I explain Cloudflare and Microsoft Azure. And I think I've got a slide for Amazon Route 53 as well. It doesn't matter. So you don't have to run all the moving parts. If running a DNS server is not your idea of a good time, you don't have to. All you need to do for the automation to work is you can take advantage of the indirection and you just add an ACME challenge CNAME to your chosen zone. And how you interact with that zone is entirely up to you. I would not recommend interacting with it by fax. Right. It just, it's, you wouldn't believe what people do on the internet these days. But right. So, but the teachable point in this entire tutorial is that all of the little moving parts of this process are completely free or completely open to interpretation. So what ACME.sh does is it keeps your certificates valid. What you do with that certificate is completely up to you. You just run another shell script and send it off to your light bulb or to your printer or to your web server. And if you want to run this on your web server, you can. Right? There's nothing wrong with running this on your web server and having it manipulate your Apache configuration or your Nginx configuration directly. That's fine. That's fair. But if you automate all the things instead of having that on every single machine, have one certification oracle somewhere in your network or two for reliability, and have that talk to all the other things. It's easier to automate that way. And that's when you're in your organization with 5,000 people with many stakeholders, cut the humans out. Humans are nice, but they make mistakes. So replace them with a machine. And your first pass at replacing them can be install a certbot-like thing on every machine and have it renew its own certificates. That's a good start. That's what certbot does with port 80. And that can be your first pass automation, but it requires you to have the internet see port 80 in your network. The second pass can be, well, it can be on my DNS server. I think that's what Tuxo is doing, is it runs on my DNS server, the internet can see my DNS server, and it works. And then the next pass iteration can be, well, maybe they shouldn't see my DNS server. I can just add a CNAME and have someone else's DNS server do it. And, fourth pass can be, well, I don't trust Trouble to do it. Let's ask Cloudflare instead because they're nicer. And you can reason about every component in the system and make it as reliable or as complicated as you like. Does that make sense? Yes.
Tips, I have two questions. Number one is, if we have a isolate network, how can I use this SSL setbot and renewal things? Because of those networks are not involved to the internet. It's a fully isolated network. Second question is how to do the demonstrations for education purpose for students. So they are not allowed to internet, have multiple domains.
Your first question is easy. Use indirection. This is basically what I've done, and the slides have a demo of this. So I use this process for putting a certificate on my printer. My printer is on the internet, but it's not exposed to anyone on the internet. It has a routable address, but you can't talk to it unless you're coming from the correct network. So my automation can talk to the printer. So there's a secure channel, the piece of string, that the certification, when the certificate is updated, it prepares a file that the printer can understand, and that's pushed to the printer. Right. So that the printer does not talk to the certbot in any way. There's another machine the printer trusts that does talk to the certbot. So the way I do it is I have a deploy hook that puts my signed certificates in a web directory somewhere, and then another piece of automation goes and downloads it from there puts it in a PFX file that the printer understands and sends it to the printer. And that all runs mostly offline. The only thing the automation has to do is fetch the certificates. And that's how I would recommend doing it for your light bulbs as well. Don't write a shell script that talks to your light bulb. Write a shell script that downloads the certificates and on a trusted machine, and have that machine talk to your light bulb. And I think for your students, it would probably be something similar. Run your certification or Oracle in a DMZ of sorts. Allow your students to write C names in an indirect zone, and then check those C names before passing them on for signing. Right. The nice thing about DNS is it's completely distributed. So if you can point an NS record somewhere the internet can see, you're done. Or you can make it more complicated. The way I do it, you can set up a hidden master server, and your public DNS server goes and fetches your zone after you do something to it. But yeah, that's another very good questions, and another good illustration of how you can isolate different parts of this for your use cases. Any other questions? We still have about half an hour, I think. I went through this pretty quickly. Should I come and do this again next year? Any other questions from anyone? No hecklers? All right. Uh-oh. I should not have said anything.
So this is the process, and by default is do you control the type of keys from the what is it, acme.ch request type? I think I saw -k.
Yes, let's go back to that. Yes, that's a good point. Yeah. I think it's here.
There you go, EC256.
Oh, right. Yeah, it's at the top of the screen. Yeah, here we go. Yeah. So acme.sh, you can control what kind of keys it generates. By default, it wants to generate RSA keys of, I think, 2K length. With -k, EC256, you're asking for EC certificates. The -- DNS flag picks the correct plugin, or picks the DNS API plugin. And then the challenge alias is just the indirection I've explained, and -d is the domain. So
Is there a reason you chose EC256 over something like ED25519?
no.
Is there a recommendation you can make?
EC256 is well supported in all the things I care about, as far as I know. And it generates nice and short strings, which are easy to base64 encode and paste into a serial terminal.
And this might be going outside the scope of what you might want to talk about, but what about the correlation between American TLA associate organizations and the EC algorithm derivation? You wouldn't recommend ED25519 because of that?
I think we could go off on a wild tangent here. I would recommend the algorithm that the thing you need to secure and the thing that needs to talk to it both support. And that narrows it down a bit. ED25519 is not quite as well supported as one would hope, whereas EC256 seems to be pretty universally supported. If you like ED25519 and both the thing you need to secure and the thing that needs to talk to it support it, then use that algorithm. If you need to support RSA, use RSA. There's still a distressing number of things that only want RSA with short keys, and acme.sh is not going to try to stop you from using those. It provides you just enough rope to hang yourself. Does that make sense? You are trying to get me into a philosophical discussion on the nature of...
No, I was just looking for a recommendation from someone who does this more often than I do.
Right. So my recommendation would be, unless you have really good reasons to use something else, use EC256, because that seems to be what currently the best supported, smallest or most compact keys, most compact certificates, and fast. I would like to live in a world where ED25519 is better supported, but it is not. So my recommendation is use EC256 because people support it. Also, not all certification authorities supports ED25519. I think Let's Encrypt does. I'm not sure about Zero SSL. So there's the third. You are still getting keys signed by someone else. So they need to support what you want signed. So you're not completely rid of the certification authorities. It's just the certification authority you're dealing with doesn't want your money or your soul. They just want to know who you are and, don't fight.
If there's no one else with questions. So this is cool, and thank you, because I actually learned something here. Do you have cool tricks so that we could stop using the SSL certs per se, or let me say this differently. Do you have cool ways of getting the records that we get into TLSA records? I still do that manually, and I'd like to automate that.
I've not automated that yet. So my putting new things online process involves add a CNAME and add a TLSA record. I've not automated that link yet, but that's a good point. That might be a topic for the next version of the presentation. That's a good point. TLSA records are good. In an ideal universe, all of this would be set on fire and we'd all be using DNSSEC. But that's not the world we live in, right? So I hope one day to give a presentation that says all of the things I have taught you for several years is now obsolete. Go and use DNSSEC instead. But we don't live there yet. More questions.
Is there a limitation of us creating subnet to use in the SSL certificates?
Yes, that's actually a good point. There are limits, and I do have a slide on them, but I'm not going to put it up because if I change between PowerPoint and a terminal, it catches fire. But both Let's Encrypt and Zero SSL have limits on how often and how many certificates you can issue. And mostly they are there to protect you from testing in production. So the limits are firm, but they're generous. If you fail to validate a domain, I think 5 times within an hour, it cuts you off for an hour and forces you to go and think. So both Zero SSL and Let's Encrypt have its sandbox environments without these limits, which issues certificates which don't validate, but which allow you to test without testing in production. So if you try to issue certificates too quickly, the robot will cut you off and put you in a timeout box. But for production, this doesn't matter because as long as you are able to validate, it will keep issuing. And the number of certificates you can issue is, I think, dozens per hour or something. So we run this on the FreeBSD.org cluster, where we have an obscene number of names with an obscene number of certificates. And we have never, as far as I know, run into reissuing or re-signing limits. We have run into the limit of the first issuing because we were testing in production and, arrow up, enter, a fixed typo, arrow up, enter again, fixed typo, fix the other typo. And after 3 typos, the robot says, cool down and come back in an hour. So don't test in production. That's a limit you will run into if you try, but you won't run into the limits under normal operation, even with an obscene number of names in your DNS. All right. I hope this was useful. I look forward to answering many more questions in the hallway for the conference. Thank you very much. Oh, were there questions from the internet? Now that I'm dismissing everyone in the room, is the internet saying I'm wrong? No questions from the internet either. All right, you can all go home now. Stop sharing. Good. I feel better without Zoom on. All right. TLSA records.